Morning, everyone. In the previous lecture, we have learned about Luting cements. We started about Luting cements. In this, we have learned the classifications, ideal qualities. We have learned about the silicate cements, zinc oxide cements, and the polycarboxylate cements. In this lecture, we are going to study about the other cements, the glass ionomer, resin modified glass ionomer, and of course the resin cements. So we are going to start with the glass ionomer cements. In 1969, a new translucent cement was developed by Wilson and the Kent. The genetic name glass ionomer cement, the trivial name was ASP, the aluminosilicate polyacrylate cement that consists of the basic glass and acidic polymer which sets by an acid-base reaction between these components, given in the McLean, Nicholson, and the Wilson. The cement possesses the advantage of both silicate cements, the translucency and the fluoride release, and the polycarboxylate cements, fineness to the pulp and the chemical adhesion to the structure. In the previous lecture, we have learned about the silicate cement that is used for the anterior filling. The quality for that silicate cement is used in this, and the polycarboxylate cement that is more polite to the pulp that quality of the polycarboxylate cement, the both qualities of the both cements has been used in this cements. Composition: the glass aluminum powder is an acid soluble calcium fluoroaluminum silicate glass, an iron leachable glass. It contains the silica oxide 24.9%, aluminum oxide 14.2%, aluminum fluoride 4.6%, calcium fluoride 12.8%, sodium aluminum fluoride 19.2%, and the calcium aluminum phosphate 24.2%. And the liquid that is used in this, the polyacrylic acid 45%, water 50%, and the modified that is added in this, the eticonic acid, malic acid, and the tricarboxylic acid, and the tartaric acid. Raw materials are fused to a uniform glass by heating them to a temperature of 1100 degrees Celsius to 1500 degrees Celsius. Lanthanum, strontium, barium, zinc oxide addition provide a radio opacity. The glass is ground into the powder having particles in the range of 15 to 50 micron. The acid is in the form of the copolymer with the eticonic acid, malic acid, and tricarboxylic acid. This causes the decrease in the viscosity, inhibits its dilation. Tartaric acid improves the handling statistics and increase the working time, but decrease the setting time. Setting reactions occur in this way. The glass ionomer sets within the 2 to 3 minutes from mixing by an acid-base reaction. The first step is the reaction with the hydrated proton from the polyacid at the basic site on the surface of the glass particle. This results in the movement of the ions such as the calcium, sodium, and the calcium ion from the glass into the polyacid solution, followed quickly by the aluminum ions. This ion then react with the polyacid molecules to form the ionic crosslinks. This insolubilized polysalts that form becomes the rigid framework from the set cement. When this setting reaction occurs, all the water becomes incorporated into the cements. Role of the water. Water is the third essential component of the glass ionomer. So, solvent for the polymeric acid, it, allow, it allows the polymer to act an acid by promoting the proton release. It is the medium in which the setting reaction takes place. Lastly, it is a component of the set cements. Biocompatibility of the glass armor. The pulp response to GIC is favorable. Freshly mixed GIC, the pH of the freshly mixed GIC is acidic 0.9 to 1.6. Mild inflammation resolve 10 to 20 days. Solubility and disintegration lower than zinc phosphate, zinc polycarboxylate, and in water less than the silicate cements. Setting time is 7 minutes, when thickness is 24 microns. Compressive strength is less than the silicate cements. Tensile strength is higher than the silicate cements. Hardness is less than the silicate cements. And wear resistance is less than the composites. Glass ionomer cements are water based, have low solubility in the oral cavity, good working time, intermediate mechanical properties, and excellent translucency. They are among the most resistant to salivary contamination, chemical bonding, and disease. The sustainable fluoride release coefficient of thermal expansion is similar to the tooth. These are the advantages. Means chemical bond, ionic bonding or the chemical bonding, sustain the fluoride release, coefficient of thermal expansion similar to the tooth. Translucent can be used with a porcelain crown, adequate resistance to the acid dissolution, low film thickness, and maintain the constant viscosity for a short time after mixing. Disadvantages include the initial slow setting and sensitivity to early moisture, contamination, and desiccation. Modulus of elasticity lower than the zinc phosphate. Initial low setting pH was assumed to be associated with the post-cementation sensitivity. Insensitive or insufficient wear resistance. Now, the resin modified GAC. Originally used the term resin modified glass ionomer as a trivial. Resin modified GAC, the cis cement was introduced in 1990s with an objective to combine some of the desirable properties of glass ionomer cement, that is the fluoride release and the chemical adhesion, with the high strength and low solubility of the resins. The polymerizable functional group were added to the conventional glass ionomer cement to achieve the rapid curing activity by the light chemical while still allowing acid-base reaction to take its course along with the polymerization. Wear resistance was also improved. Powder contained the consists of the iron leachable glass and initiator for chemical and the light curing. Liquid contain four main ingredients, that is the methyl acrylic resin, this GMO, which enable the polymerization reaction, a polyacid which react with the iron leachable glass to allow the acid base reaction, hydroxyethyl methacrylate, HEMA, hydrophilic which enable both the resin and the acid component to coexist in an aqueous solution. HEMA also takes part in the polymerization reaction. Water to allow ionization to the acid component so that the acid base reaction can occur. Other components include the polymerization activator and the stabilizers. These cements can be chemically cured, light cured, cured. Chemical cured and light cured acid base reaction, or the tri cured, chemical cured, light cured, and the acid base reaction. Acid base reaction is induced after the powder and the liquid are mixed, forming a polyacrylic salt. Polymerization, the primary setting reaction, is initiated as soon as the sufficient free radical becomes available. Slow acid base reaction is responsible for the final maturation and strength for the cement, while polymerization reaction provide the initial set. The chemical activated polymerization of the resin modified glass ornament cement is referred as a dark cure. Advantages: the compressive strength, diametral tensile strength, and the flexural strength are dramatically improved in comparison to the zinc phosphate, polycarboxylate, and glass ionomer cement, but is less than the resin cements. Less sensitive to early moisture, contamination, and desiccation during setting, and less soluble than the glass ionomer cements because of the covalent cross-linking of the polyacrylic salt from free radical polymerization. Easy manipulation and use. Adequately low film thickness. The fluoride release similar to the conventional GIC. Polymerization is not significantly affected by the usual containing polymerization material as long as the provisional cement is completely removed with thoroprophylaxis. Minimal post-operative sensitivity, high bond strength to most dentin. Disadvantages: the dehydration shrinkage due to the glass ionomer component may create stress fracture and expose cement tooth restoration interface. HEMA is responsible for increased water absorption, subsequently plasticity and hygroscopic expansion. Although rare, may elicit an allergic response due to the free monomers. Cement bulk is very hard and difficult to remove. Anhydrous luting cements, compomer. The previous one we have learned about till now we have learned about the water based and that is now the anhydrous luting cements. Compomer, the polyacid modified composites, introduced in a European market as a restorative material in 1993. This cement also lies between the glass ionomer and the resin component The predominant characteristics of microfill resin composites. Composite is derived from the composites and glass ionomer having fluoride release capability of conventional GIC and durability of the composites. Compomers for the luting purpose are available as a two-component system, either powder liquid or a two-piece system. Powder is made up of strontium aluminum fluorosilicate, metallic oxide, chemical activated, and the light activated initiator. Liquid polymerizable methacrylate carboxylic acid monomers, multifunctional acrylic monomer, and water. Because of the presence of water, these materials are self-adhesive and an acid-base reaction starts at the time of the mixing. The tensile strength, flexural strength, and wear resistance of the compomer is superior to the conventional glass ionomer, but less effective than the resin composites. Now, the main topic, the resin cements. The methyl methacrylate beads resin cements are developed in 1950s by Dr. Raphael Bowen. By Dr. Raphael Bowen in 1963, developed the first multifunctional methacrylate used in dentistry called BIS-GMA of the Bowen's resins. Resin cement have high bond strength both due to the tooth structure and the pore size, high tensile and the compressive strength, and the lowest solubility of the available cements. The flexural property include the modulus and the strength are important to prevent debonding during function. And resin cements have both a high modulus and the strength. In fact, they have the highest strength of the cement currently in use. Disadvantages of resin cements are associated with their technique, sensitivity, and difficult with the cleanup resins. Sorry. The resin cements may change shade during curing and can darken during their lifetime. Based on the methyl methacrylate based resin cements were developed in 1950s but had poor physical property, that is high polymerization, shrinkage, and increase of micro leakage because of the low filler content. They also had the high residual amine levels, which contributed significant color shift after polymerization. Based on the aromatic methacrylate, the BIS-GMA, that is propane, resins can be described as aromatic ester of the dimethacrylate, synthesized from an epoxy resins and methyl methacrylate BIS-GMA. BIS-GMA is extremely viscous and a low viscosity dimethacrylate, such as triethylene glycol dimethacrylate, TEC-DMF, is blended with it to reduce the viscosity. Resin cement used today are composed of the resin matrix of the bis-GMO urethane dimethacrylate and filler of the inorganic particle to ensure thin film thickness. On the method of polymerization, at the on classification of the resin cements, on the method of polymerization as the chemical cured, light cured, and dual cured, classification by the adhesive scheme, total etch, self etching, and the self adhesive. The self-adhesive resin cements may be referred as all-in-one resin cements or universal cement. Resin cements by polymerization mechanism. Uh, these are the chart for the resin cements. Light curing method, the photoinitiator activated by the light. Characteristics include the increased working time, decreased finishing time, and color stability. Indication where the aesthetic restoration, metal free restoration, and the thin cementing and the translucent ceramic. Dual core the chemical and the pure by the chemical in the light. Characteristic for the dual core is the body strength, aesthetic, and easy to use. Indications can be used with cement when the cement thin, opaque ceramic, and metal for restoration. Chemical cure, the chemical reaction of the two material mixed, self curing. Used in the area where the light cure is difficult, like post and road. And the indication are the metal restoration and non-decomposed ceramic restoration that prohibit the curing unit from adequate polymerization of the resin surface. Procedure. The adhesion to the enamel occurs through the micromechanical interlocking of the resin to the hydroxyapatite crystal and the rods of the etched enamel. Adhesion of the resins to dentin is more complex and involves penetration of the hydrophilic monomers through a collagen layer, overlaying the partially demineralized appetite of the H dentine. Adhesion to a dentine with resins required multiple steps, and beginning with the application of an acid or a dentin conditioner to remove the smell layer, the smell plug, and open and widen reticles, and demineralize to up to the 2 to 5 microns of the dentin, millimeter of of dentin. The acid dissolves and extract the appetite mineral field. It normally covers the collagen fibers or the dentin metals and upon open 20 to 30 channels around the collagen fibers. After demineralization, the primer or wetting agent such as the HEMA is applied. The agent is bifunctional, that is, it is both hydrophilic, which enables a bond to the dentin, and hydrophobic, which enables a bond to the other side. The primer is gently dried so as not to disturb the collagen network, but to remove any remaining organic solvent or water that could obstruct the contact of the resin adhesive with the primer. Adhesive resin is then applied to the primed surface to stabilize the primer infiltrate demineralization dentine to penetrate into the dentinal tubules, as shown in the diagrams. The surface treatment of ceramic prior to the resin cement fill. The surface treatment of the ceramic depends upon the composition and strength of the ceramic material. Options include the etching, sandblasting, or use of the Roca-Tech or Kojic technique. Etching is effective only for the silica containing material. Feldspathic portion of the lithium disilicate and lucite containing slabs. Etching the intensity of the inner surface, it increases the surface area available for bonding. Sandblasting or treatment with the Rotex system, the 3M that is available with 3M, can be used on the intactly surface prior to bonding high strength ceramic material. For high strength core material, a light dusting alumina particle of less than 50 micron for the short period is recommended. Sandblasting is not recommended for the low strength ceramic. Rocatex soft at the constant system is an effective method for increasing the bond to high alumina cores, feldspathic porcelain, and zirconia core material. It coats the cementing surface of the ceramic restoration with the silica sealant, is then applied to this layer and dried thoroughly. The sealant bonds to the silica coated on the ceramic, which bonds to the resin cement. By this mechanism, a high strength non-silica containing ceramic restoration is bonded to the tooth. Advantages: the superior compressor and the tensile strength 20 to 50 micro MPa with a low solubility. Micromechanical bonding to prepare enamel, dentine, alloy, and ceramic surfaces. Available in a wide range of shades and translucencies. Disadvantage: the meticulous and the critical manipulation technique, high film thickness, marginal leakage due to polymerization shrinkage, severe pulpal reaction when applied to cult vital dentine, offers no fluoride release or uptake, low modulus of elasticity, so cannot support the long span prosthesis. Now the self-adhesive resin cements. In order to improve the adhesive bond of the conventional disc chamber resin cements, adhesive monomers have been added and that will enable the chemical bonding to both the tooth structure and the suitably prepared metal surfaces. This includes a bifunctional phosphate monomer, 10 methaacryl decyl dihydroxy phosphate (MDP), developed in the 1981, and carboxyl monomer, the 4-methoxy ethyl trimaldehyde anhydride, 4-meta. The affinity of this monomer for the metal oxide present on the base metal alloy without the need of the acid etching. However, these resins have low affinity for the precious metal alloy due to the lack of the surface oxide coating and low chemical reactivity requiring need for some surface modification to achieve the chemical bonding. Tin plating, silica coating, and tribochemical coating or use of the new metal primers. This material required no intermediate step to bond to the enamel and dentin. A separate adhesive bonding agent is not required, saving time and simplify the procedure. Self-adhesive cement leave the dentin smear layer and procedure and produce an intermediate bond to a dentin compared to the total edge cements. contain acrylic or diacrylic monomer and a specific adhesive monomer that are sufficiently acidic to produce their self-adhesive properties. Polymer degradation over time is still an issue. Metalloproteinases (MMPs) are the fossilized within the mineralized dentin and can be released and reactivate during the bonding. These endogenous collagen, uh, collagenollytic enzymes are on the collagen fibers and needed for bonding, and the slow degrading enzymatic action is beyond the control of the even the most meticulous clinician. The recommended pre-treatment of a dentin with 0 to 2% fluorohexidine gluconate with a pH of 6%, which prevents the extraction of the endogenous enzymes, is recommended. The hybrid acid-base based glass ionomer, ceramic CNB, a revolutionary cement with a high biocompatibility. Only one formulation is presently known that is based on the calcium aluminate in the glass ionomer. Cement is a water-based hybrid composition comprising of the calcium aluminate and glass ionomer component that is mixed with the distilled water. The material has been demonstrated to be bioactive. The setting mechanism of the ceramic CNB is a combination of the glass ionomer reaction and the acid-base reaction of the type occurring in the hydraulic cement. The incorporation of the calcium aluminate component provides several unique properties compared to the conventional GICs. After 1 hour, the pH is already neutral, and after 3 to 4 hours, it reaches a basic pH of 8.5. This means that the fully hardened material is basic. The basic pH is the most important prerequisite for the material to be bioactive, that is, creating apatite on the surface when in contact with the phosphate containing solution. The material produces an excess of the calcium ion, which also contributes to bioactivity. The incorporation of calcium aluminate fixes the GIC structure and hinders the ionomer glass from the continuously leaking over time. Ceramide CNB has an initial fluoride release compared to the glass ionomer, although the release tapers over time. The unique properties such as apparate formation, remineralization develop quickly and continue to be active. These are the chart about the different properties of the luting cements, and the ideal is a 25. The film thickness should be 25 micron. As you can see, the working all describing the film thickness, working time, setting reaction, retention, compressive strength, tensile strength, elastic modulus, bond distance to density, solubility in water, and excess cement removal. Compare. It is a comparison of all the cement, and the ideals was also given in the first row. Now the clinical applications and the use of this cements. The zinc oxide regional. The cement has an obtaining effect on the pulp, a high film thickness, and have limited its use. The usual containing temporary cements that are used prior to the indirect bonding restoration reduce the bond strength of both total and self-leaching adhesive system to density. The film thickness of zinc oxide regional cements make them unsuitable for the cementation of many contemporary indirect restoration. Non-eugenol formulation should be used as for provisional luting cement, when a resin-based luting cement are used for the permanent restoration. Zinc phosphate cement. The post-cementation hypersensitivity is indeed a frequently occurring chemical problem, which either resolve over time or may result in the need for alternative treatment. The set luting material may be biocompatible. Post-cementation discomfort is known for unfavorable side effects when using this cement. Varnish reduces the retention of the restoration by as much as the 50 microns. The cement retains the prosthesis purely by the mechanical, means the taper length and the surface area of the filtration are therefore critical to its success. Cement is routinely recommended for the cementation of the prefabricated and the cast post, crown, FPDs and metal inlays and the onlays. The polycarboxylate, the cement causes little or no irritation to the pulp, even at a remaining dentin thickness of 0.2 mm. It is believed that the long molecular chain of the polyacrylic acid prevent penetration into the dentinal tubules. Currently, polycarboxylate cements are mostly used for long-term temporary cementation. Polycarboxylate cement exhibits a significantly greater plastic deformation than zinc phosphate. Thus, it is not well suited for use in the region of the higher masticatory stress or in cementation on long span prostheses. Vital or the sensitive teeth with the preparation close to the pulp or is the cementing single unit or short span ridges in the area of low stress. Means these are the use. Glass ionomer cements are used mainly to cement metal or metal ceramic restoration with adequate retentive at the resistant form. They are contraindicated for the low strength all ceramic restoration. Compomer cement for the process with metallic substrate. Resin modified state. The modified glass ionomer cement have a successful history of use for metal ceramic, high strength ceramic restoration, as well as for the metal and the composite fiber post. Potential for substantial dimension changes contraindicate their use with all ceramic feldspathic restoration. The resin modified glass ionomer provide inadequate retention with the preparation with poor retention and resistance form. Resin cements. The resin cements are most versatile and widely used cements for non-metallic restoration, resin bonded fixed partial denture, ceramic crown, porcelain veneer, as well as the ceramic and the resin composite inlays and onlays. The static resin composite cements are used for the veneers and are supplied in multiple shades, viscosity, and aesthetic try and paste. Bonding of the high strength ceramic crown will increase crown retention to teeth with short clinical crown, such as for the posterior. Advantage of light cure cement is their color stability compared to the dual cure and chemical cure resin cement. These cements are therefore suitable for aesthetic restoration and metal-free restoration. Dual polymerized resin cements are indicated when ceramics too thick or too opaque to allow transmission of the light through it. These cements are used for the metal-free restoration where light curing may be performed to quickly seal markings. The metal restoration, enrolled post and ceramic restoration that prohibit the curing light from adequately polymerizing the resin cements. Again, this is the chart where all the cements and the crown was indicated, and the good choice and the a recommendation for the good choice and other this cement can be used with the with crown is given. This chart is taken from the Indian Prosperity Society Journal. This again gives the clinical condition, luting agent that is type preferred, and luting agent to be avoided with this. Luting cement for the implants. Last topic for today. The screw retain and the cement retain restoration is always a topic for debate. A cement retain restoration are better than the screw, despite of the margin adaptation, occlusion, aesthetic, passivity, and cost reduction. But the disadvantage is difficulty in retrieval and accessibility. The screw retain restoration have more technical complications, but mostly preferred because of the ease and retrievability and higher biological compatibility. Both temporary or the permanent transfer cement depend upon the loading protocol and retention required and retrievability. Temporary cement can be used where the less retention is required or in the case of progressive loading with a sufficient abutment height, width, taper, accuracy of fit, superstructure, and number of the abutment present or retrievability is required. Excess temporary cement are more easily removed. The less technically sensitive, cost effective, and the fractional strain relaxation. Temporary cement are solubility, low retentive strength, and the poor radio density properties. Permanent cement overcome the major disadvantage of the provisional cement, that is the retentiveness, and have enhanced the sealing ability with the less chances of debonding. Resin cements have been proved to the most retentive building cements and ideal for the definitive cementation of the cement retained implant prosthesis. Again, this chart has been given for the plant retained prosthesis. Summary. A luting agent primary function is to fill the minute void between the entire restoration and growth. and mechanically lock the restoration in place to prevent the dislodgement during function. Resins are typically formulated for a specific function or restoration and offer strength, aesthetic, flexible working time, and very low solubility, yet are technique sensitive, expensive, and hard to clean up. The glass ionomer offer good strength and optical properties, plus the potential for fluoride release, recharge, but may have short working time and are sensitive to moisture or dehydration early on and take time to fully set. The resin modified glass ionomer are hybrid, dual phase material which are manipulated like glass ionomer but set quicker and are stronger. Zinc phosphate cement used successfully for over a century to lute the well-fitting material metal and metal ceramic definitive restoration is a very inexpensive rigid material which displays very high early compressive strength, yet acidity and solubility can be problem. Polycarboxylate cement, a hybrid of the zinc phosphate, has low compressive strength but high tensile strength and may be less injurious to the pulp. The zinc oxide eugenol and the zinc oxide non-eugenol cement typically have good sealing ability, but their relatively low compressive tensile strength, inherent brittleness, and high solubility limit uses to provisional restoration. These are the references. So this is all about the luting cement that is used in the dentistry. The starting their history and what is used for now for the all ceramic metal and the metal portions fuse the metal throat. And of course, we have learned also about the implant restoration. Thank you.